We have a question about some inequalities, the polynomial and the rational inequalities. And this is going to be like a 3 or 4 part series again. And I'm going to begin with the quadratic inequalities. Actually, so it's a special case of the polynomial inequalities. And this problem right here actually came out of 4.3. This will also be on the test. It's not a polynomial inequality, but this is kind of the idea where we're getting this concept at. Back in 4.3, we talked about how to graph f of x equals x squared minus 6x plus 5. And if you notice, that is in quadratic form. And it's basically a parabola. And I came over here and I found the vertex already. And the vertex is, remember, is found by negative b over 2a. And that was 3. And you plug 3 back in, that gives you negative 4. So the vertex is down here at 3, negative 4, right there. This is 3, negative 4. I also found the x-intercept, so I can factor this out. X minus 5 times x minus 1. So the x-intercepts are at 1 and 5. And if you notice, that's exactly what I have right there. And for our purposes now, I went ahead and drew the graph. Now, back in 4.3, you had to do other things as well. You had to actually draw something called the axis of symmetry. But really, all I wanted on this part right now is just kind of the shape of the parabola. Okay. And 4.5, when we had to do quadratic inequalities, you had x squared minus 6x plus 5 greater than or equal to 0. If you notice, it's the same as my function. And what this is basically wanting to know is, when is this function greater than 0? So as we all know, something is greater than or equal to 0 when it's above the x-axis, and it's less than 0 when it's below the x-axis. So if this is the same as my function, all I'm actually wanting to know is, where is it above the x-axis? So it's above the x-axis right there and right there. So what values of x make that happen? Well, according to the graph, it looks like it's on the right side of 5 and on the left side of negative 1. That's when it's above. Actually, when it's below is between 1 and 5. So if I was wanting to solve this, really, if I want to look at the graph, I can come up with the answer right away. So I know the answer before I even start. It's negative infinity to 1 bracket union 5 to infinity. Now, the reason for the bracket is because it says greater than or equal to. So equal to 0 is also good, which basically means it's not above the x-axis, but it's on the x-axis. And that's why the bracket's there. Now, if this said just strictly greater than, no brackets, just parentheses, which means you wouldn't include it, be exclusive to those numbers. Now, the thing about these graphs, and I'm going to try to do the graph on every one of these problems, but when you're doing this for real, for your homework and for your test, you don't really have to show the graph to do these problems. All you have to really is think from 2 dimensions down to 1 dimensions. So what you're trying to do is just draw the x-axis. So you look at the x-axis, so I'm referring to just this axis right here. So this is what I'm referring to. I'm not really going to draw the y-axis. Now what I'm going to do is I'm going to factor this. So it's x minus 5 times x minus 1 greater than or equal to 0, just like it was over here. Now I'm going to locate the x-intercepts, 1 and 5. 1 equals 0, 5 equals 0. So when you do these polynomial inequalities, you're trying to find where the x-intercepts are at. Now, instead of drawing the graph, I'm going to use the end behavior of this thing. X squared minus 6x plus 5. If you remember back in 4.3, some of the things that you had talked about was the end behavior. And the end behavior is when the x squares, they go in the same direction. They either open up or open down, one or the other. And you look at that by the leading coefficient, which is 1. So as you can tell by the graph, it opens up. Now, if I don't have the graph here to look at, you'd come over here and say, okay, x squared minus 6x plus 5 is still the same idea. So we know the ends are going to go up, okay, just because the leading coefficient is positive. So since both ends go up, on the extremes of the x-intercepts, it's got to be up in here and up in here, which basically means since these are x-intercepts and they have odd degree, they cross. So if they have odd degree, it's down here between the numbers 1 and 5. So between negative infinity to 1, it's up here, which is above. Between 1 and 5, it's below the little valley down here. And then on the right side of 5, it's up here. So we're looking for the greater than or equal to 0, so you can get the answer based on that. So negative infinity up to 1, union 5 to infinity. So, um, so in other words, it's the same idea. You're just wanting to know this. All this is asking is, when is the function above the x-axis? If it was less than 0, they say, well, when is the function less than this? So you could do these problems from 4.5 by doing the problem like you did back in 4.3 by drawing the whole graph and just looking at the graph and trying to determine where it's greater than 0. So that's the idea of these types of problems, whether they're polynomial, quadratic, rational inequalities. They all work pretty much on the same premise. When it says greater than 0, when it's above the x-axis, when it's below. And again, you can draw the whole graph if you have a lot of time to do that. And but if you don't want to have to draw the whole graph, you go from two-dimensional to one-dimensional. So you just draw the x-axis and not worry about the y-axis. So the important things you're going to be looking for are x-intercepts and vertical asymptotes if they have vertical asymptotes. And since this is a parabola, there's not many vertical asymptotes. So for right here, just the x-intercepts, knowing a little bit about the end behavior, both arms go up. So it's up here, down below here. And since this is saying greater than, see, greater than 0 is just lingo for above the x-axis. So, and it's above the x-axis here and there. So that's the solution. And that's it.